All right, let's dive in. Today we are tackling, well, pretty much the biggest story there is. It's a journey that starts 13.8 billion years ago with the very first spark of existence, a story that connects the dust between the stars to the very atoms inside you. And it all leads right back here, to this fragile blue planet and the choices we have to make for its future. I mean, have you ever just looked up at the night sky and wondered, how did all of this happen? And maybe more importantly, what happens next? It's a huge story, so we're going to break it down. First, we'll hit rewind and go all the way back to the beginning of time itself. Then, we'll fast forward to today to really understand our own planet and the massive role we play in its story. So let's get to it. Okay, part one, from the Big Bang to starlight. We are winding the clock all the way back to a time before there even was a clock to wind. So our guide for this part of the journey is astronomy. You can think of it as the ultimate cosmic detective story, right? And the main clue we have is ancient light that's been traveling for billions, and I mean billions of years, carrying the secrets of the beginning of everything. 13.8 billion. Just let that number sit for a second. That's our starting line. Not 1,000, not 1,000,000, 13.8 billion years in the past. This is the moment scientists believe our entire universe just blinked into existence. Now, what's so cool here is how this timeline clears up a huge misconception. The Big Bang wasn't some explosion in space. It was a sudden, mind-bogglingly fast expansion of space itself. As you can see, it went from this single, incredibly hot and dense point to a phase of massive inflation. And then, as it cooled down, gravity could finally get to work, slowly pulling bits of matter together to build the very first stars and galaxies. So, you might be asking, how do we actually know this? Well, this isn't just some wild guess. It's backed by some seriously solid evidence. For one, the universe is still expanding. We can see it. We can watch galaxies flying away from us, kind of like dots on a balloon that's being blown up. And second, there's this faint cosmic hum everywhere we look. It's the leftover heat, the afterglow of that first moment. Scientists call it the cosmic microwave background. You can think of it as the universe's baby picture. So, out of that early cosmic soup, the first stars were born. And as this shows, stars have lives. They're born in these massive clouds of gas and dust. They shine steadily for billions of years. Our own sun is right in the middle of this main sequence phase right now. And then, eventually they die. And when they die in these huge explosions, they forge all the heavier elements, like the carbon in your cells and the iron in your blood, and scatter them across the galaxy. And here's the kicker. The stuff that makes up our planet and us was literally cooked inside a dying star. We are, and this is not an exaggeration, made of stardust. Part 2. Our home in the cosmos. Okay, so we've got stars creating the building blocks for planets. Now let's zoom way in, from the scale of the entire universe to our own little neighborhood, the solar system. So about 4.6 billion years ago, the leftovers from one of those ancient exploded stars, just this huge cloud of gas and dust, started to swirl and collapse in on itself thanks to gravity. Right at the center, a brand new star ignited. That's our sun. And all the leftover bits and pieces started clumping together to form the planets. This chart really shows you who's the boss in our solar system. I mean, it's not even a contest. The sun makes up 99.8% of all the mass here. Everything else, Earth, Jupiter, all the other planets, every asteroid, we're all just part of the leftover 0.2%. That incredible mass is what gives the sun its immense gravity, the force that holds this whole cosmic neighborhood together. And orbiting that star, we have the whole family of 8 planets. You've got the small rocky worlds on the inside, Mercury, Venus, Mars, and then you cross the asteroid belt and get to the absolute giants, the gas and ice planets. And right there, nestled in that perfect Goldilocks zone, not too hot, not too cold, is the third rock from the sun, our home, Earth. It's amazing how 2 simple cosmic movements basically define our entire lives. Earth's daily spin on its axis, that's its rotation. That's what gives us day and night. And its long, year-long journey around the sun, its revolution, well, that's what gives us our year. And because of its tilt, our seasons. Every single calendar is based on this beautiful, predictable celestial clockwork. Now let's throw our moon into the mix, and you get this intricate 3-body dance. The constantly shifting angles between the sun, the Earth, and the moon are what give us the phases of the moon every month. And when they line up just perfectly, we get those spectacular solar and lunar eclipses. And all the while, The moon's quiet gravitational tug is pulling on our oceans, creating the constant, steady rhythm of the tides. Part 3. Earth, a living system. Okay, this is where we make a huge pivot. We've just traveled across billions of years and unimaginable distances in space. But now we're coming home. Because looking out into the universe is amazing, but understanding our own fragile planet, well, that's absolutely essential for our survival. The best way to understand Earth is to stop thinking of it as just a big rock. It's a single living system. Scientists break this system down into 4 big interconnected parts. You've got the atmosphere, which is all the air, the hydrosphere, all the water, the geosphere, that's the land, the rock, and the biosphere, which is all of us, all living things. The most important thing to get is that you can't mess with one of these without affecting all the others. Here's a perfect example of how that works. Let's say a volcano erupts. That's the geosphere, right? Boom, it pumps tons of ash and gas into the atmosphere. Well, that can block sunlight, which cools the climate, which then affects all the plants in the biosphere, and can even change rainfall patterns in the hydrosphere. See? It's all one big chain reaction. Part 4. Our planet. Our future. So, for billions of years, these systems have been working together in a really delicate balance. But what happens when a totally new force comes along? One that has the power to change every single one of those spheres, all at once? Well, that force is us. And the result of our impact is something we call climate change. Let's be really clear here. This isn't about one hot summer or a weird winter. We're talking about a fundamental, long-term shift in the planet's entire operating system, its average temperature, its weather patterns. And it's being driven primarily by what we humans are doing on a global scale. So how does it work? Well, the basic idea is the greenhouse effect. Our atmosphere has these gases that act kind of like a blanket, trapping the sun's heat and keeping Earth warm enough for life to exist. That's a good thing. The problem is, by burning fossil fuels and clearing forests, we've been pumping way more of these gases into the air, essentially making that blanket thicker and thicker and thicker. And the effects of that extra trapped heat aren't some far-off prediction anymore. As you can see, they're happening right now. And this really gets to the heart of the issue, our energy choices. On one side, you have renewable resources like solar and wind. They basically never run out. But on the other side, you have the non-renewable fossil fuels that have powered our world for centuries. Not only will they eventually run out, but burning them is exactly what's making that atmospheric blanket thicker every single day. This leaves us with a pretty massive challenge, right? And the solution, or at least the goal, has a name: sustainability. It's a really simple but powerful idea. How do we live our lives and meet our needs today without wrecking the planet for the people who come after us? It's all about finding that balance between progress and protecting our home. And this is where our whole cosmic journey comes full circle. Looking out into the vast, cold emptiness of space really teaches you just how impossibly rare and precious this one living planet is. Understanding where the stardust came from helps us appreciate the ground beneath our feet. And understanding our Earth, how it all works, and how we're changing it, that's the first and most important step in protecting our future.